We're going to talk about soft goods and hardware that we use in our rescue systems. It consists of rope and cord and webbing from the soft goods side. And we are going to deal with dynamic and static ropes. Static rope is usually used in the rescue situation. The dynamic ropes have stretch in them, more important in a climbing situation. And we generally use our standard 11mm rope like this one, which is about 7/16 inches. And it's called a kern mantle rope because it has a kern, which is the inside, gives it the strength, all the fibers of nylon, and a mantle around the outside, which gives it its protection from abrasion and gives it a little bit of stiffness to tie things. We talk about the strength of our components in kilonewtons, or KNs, so you think of them as Kens. If you think of a person named Ken who weighs about 225 pounds, you know about what the strength of one Ken is. It's to about 225 pounds. So if this static rope at 11mm, its strength is about 30 Kens, which means if I was going over the edge as one Ken and I was going to get a rescue victim who was another Ken, I would need 2 Kens of strength. And since this rope has 30 Kens, it has plenty more than I need. We'll talk about safety factors later. As soon as you tie a knot in this rope, then its strength goes down about 1/3, so we go down to 20 Kens. So an 11mm static rope with a knot tied anywhere in the system is going to have about 20 Kens or 20 kilonewtons of strength. Now if we go down one size smaller, this is an 8mm cord, made up the same structural process, usually called a cord as it gets smaller. And the strength, as I mentioned, comes from the number of fibers. An 8mm cord has half the fibers in its area as the larger rope, so therefore it has half the strength. So we're looking at 15 Kens or kilonewtons in this, and with a knot in it, we're looking at about 10 kilonewtons of strength. The other commonly used soft good is webbing. This is 1-inch webbing. It's the standard that we use. It's a tubular webbing. You can see that it's a tube, which could be made by the way they weave it or by sewing the edges. And this webbing again gets its strength through the number of fibers that are here. And its strength can vary quite a bit depending on the manufacturing, so we estimate it's about the same as the 8mm cord we saw before. So this is about 15 Kens or 15 kilonewtons of strength, and with a knot in it, it's reduced by 1/3, so it becomes about 10 kilonewtons of strength. So those are the soft goods. The most important hard good we use is a carabiner. Carabiners with locking gates so that we don't have to worry about them coming open. And we trade off between using steel, which is very strong, and using aluminum like this one, which is a little lighter but still has plenty of strength. And again, the strength varies depending on the manufacturer, but these are standard at 22 Kens or 22 kilonewtons in their axial loading, pulling this way. If you pull the direction of the gate, this is much less strong. So this is at 10 kilonewtons this direction, and if the gate is open for some reason when you're pulling on it, it's only 9 kilonewtons. So we want to make sure that the rope is pulling on the axial length along the spine here, and that the gate is locked closed so that we get the full 22 Kens or 22 kilonewtons of strength.